Let's say you're riding along in your autonomous car and a person steps out in front of you. Your cameras see him, of course, and you do too. Hey, wait, I know that guy. Isn't that Bill? He owes me like 20 bucks from last year sometime. And then your vision system needs to process a bunch of video data fast so we can slam on the brakes. Phew, that was close. Do they have automatic, hey, watch where you're going announcements programmed into these things yet? Well, now at least I have a chance to get that 20 bucks back, Bill. Hi, I'm Amelia Dalton, host of Chalk Talk. In many applications, AI and vision algorithms have to be run at the edge, right where the action happens. There's no time to upload a bunch of stuff to the cloud and wait for a rainy day to find out what your camera saw, way back whenever. My guest today is Pulin Desai from Cadence Design Systems, and we're going to talk about specialized embedded processor IP for AI and vision with Cadence's Tensilica Vision Q6. And before we get started, don't forget to click that link. There you can find out more information about Cadence's Tensilica Vision Q6. Hi, Pulin. Thank you so much for joining me.
Yeah, it's good to be here. Nice talking to you.
Okay, so for starters, let's look at some use case examples for what's happening in embedded AI and vision these days. AI and vision are even making their way into mobile phones, aren't they?
Yeah, that's true. So let's talk about that. On this, you are looking at a picture we took at MediaTek's booth at Mobile World Congress. Here, you're looking at this young lady in front of a camera where MediaTek is demonstrating their AI accelerated face detection. And the main thing that they want to show over here is that because it's AI accelerated, it is robust. So even though she's not facing camera, and if her face was covered with hat and glasses, so in fact, they had glasses, hat. She also has scarf. The camera would detect her face. So the AI is very robust. The other thing is that they are doing this AI on APU. They call it AI processing in it. And the main reason to do this thing on APU is compared to CPU or GPU, it is much lower power. And because of that, it gives them a longer battery life. That's the main thing, that you want a longer battery life on your mobile phone. And that's the reason they use APU. And at Mobile World Congress, when they announced this Helio P60, they confirmed that this Helio P60 was using Vision P6 and AIDSP as APU in it.
Got it. Okay, so it seems like power is everything in mobile. Yes. Have you got any other mobile examples?
That's correct. In fact, we are in top 2 mobile suppliers out of top 5. So you already heard about the MediaTek. Let me talk about Huawei. Huawei Mate 10 phone uses high silicon 970 application processor, and Kirin 970 uses Vision P6 as a vision and imaging processor. And they uses that one for HDR video, hybrid zoom, image stabilization. So various vision and imaging application they offload from CPU GPU to our Vision DSP. So on the left hand side you see a picture with HDR off and HDR on. This is a classic situation with HDR where you see a very bright light and there is a disparity in intensity, and because of that, when you try to take a picture, this mug and the joker that's in the mug, the face becomes very dark if the HDR is off, and once the HDR is turned on, you start getting the detail out of this image. And this is what happens when you try to take a picture of your face with a bright light behind a window. Your face becomes very, very dark. And then with an HDR processing, you can basically remove that and get all the details out in the image. So this is another example of a Vision DSP being used in a mobile application.
Okay, cool. So apart from mobile applications, are there other markets where you see your vision and AI DSPs being used?
Yeah, so mobile obviously is a very high volume key market where the low power is very important, but other areas low power is very important. One another example I can tell you is a company called Geo Semiconductor. Geo Semiconductor uses our Vision P5 DSP to offload computer vision. So they call it a computer vision processor. They use our Vision P5 in the GW5400 product to do vision processing, to do pedestrian detection, object detection, blind spot detection. So their target market is automotive for their intelligent rear view camera. So, most of our car today have a rear view camera. When you put a car in the reverse, you can see the rear view, but they basically just give you the rear view. But by putting this intelligent, it can start detecting and giving you the pedestrian object detection, blind spot detection, basically makes the camera intelligent. But the main reason they want to offload this thing on a computer vision processor like a Vision P5 is because they want low power. The reason they want low power is that their product will be used close to the camera in what you call a zero airflow environment. And because of the zero airflow environment, it has to be low power. And this is the main reason they are using our Vision P5 DSP.
So that needs to be low power because of low cooling. Now, can we take a look under the hood and see how the data flow is typically put together in these kinds of applications?
Yeah, so if you take a look at it, we are primarily looking at connecting in a pipeline where a Bayer sensor, what image sensor, which is also called a Bayer sensor, is used. So if you go from left to right, information comes from this sensor and it is what is called in a Bayer format. And then usually our customer will use it to do a noise reduction in that Bayer format. And usually when the pixels are very small, 1.1 micron, 1 micron, 0.9 micron, this is where our customer will use it. And then ISP, which converts Bayer into RGB AYU, usually our products are not used for that. But after that is what you call the post-processing. This is where the classic use case is the 2D, 3D noise reduction, HDR, WDR, super resolution. This is what you saw the Huawei's use case. And then after that, computer vision or AI processing, where classification, object detection, segmentation, those are all the use cases that our customers use our DSP for.
So it seems like a lot of these applications are using a combination of both AI and vision acceleration, right?
That's correct. So what we are trying to show you over here is a situation that moving forward, all this application face detection, HDR, bokeh, is looking at a use case where both the applications are needed, vision and AI. So if you take a look at face detection, I talked about the face detection is actually using AI, but before the face detection uses AI, there is going to require, let's say, for example, multi-scale pyramid, which is a vision operation. Then you take a look at HDR. HDI processing is a classic vision or imaging application. You can think of it, but instead of doing a simple situation where you take one image with a higher exposure and another image with a lower exposure, you could apply AI first and do a scene detection and finding out what type of situation the scene was done, then apply HDR and make it an intelligent HDR. The same way with bokeh. So bokeh is a situation where you want to take an image and you say, I want to focus only on a certain part of that image and other part I want to blur. So you and I have been using bokeh with our point and shoot camera or digital SLR, where optics are usually used to do the bokeh. Nowadays also you have stereo camera to do the bokeh, but moving forward, bokeh can be done with a single camera where you can use AI to the segmentation, and you can segment out the image of the face, for example, if that's what you want to focus, and then other could be unsegmented, and that's where you can use the blurring. So this is what we are showing you, that all these applications are using both vision and AI. It's a mix of both, and a camera pipeline needs to be able to do both, and a vision DSP needs to be able to do vision and AI both.
Yeah, that makes sense. And it seems like performance is a key factor in all of these applications, right?
You're right. What we are seeing that our vision and AI DSPs are being used in all these markets. I mean, my simple way of saying that wherever there is an image sensor, wherever there is a camera, there is an opportunity for a vision and AI DSP. So the mobile, AR, VR, handset, surveillance camera, automotive, drone, and all this market, one reason or other, are looking for a higher performance. So if you look at the mobile, maybe moving forward, going from one camera to more 2 or a 3 camera. Now you want to do from a still resolution the video capture rate. On AR, VR, you want to do it at a lower latency. For the surveillance camera, same thing, resolution is increasing. So all these applications or all these target markets, the need for a speed is increasing.
So we've been through the use cases and the requirements, and we've talked about performance. But what are some of the strategies we can use to get the performance we need?
So all these areas, our Vision DSP is used, and then as you require more performance, there's various ways to increase the performance, and all of those strategies, there are pros and cons. So we are a VLIW SIMD machine, and one of the easiest thing we could do is increase the SIMD width or increase the VLIW slot. So we are a 64-way 8-bit SIMD machine. We can just say, oh, double the SIMD width. Oh, we have 5-slot VLIW. Just increase the VLIW slot. Sure, it gives you more parallelism, but there is a con. It's very difficult to program. It's very hard to achieve the efficiency and efficiently utilize all those SIMD or all that VLIW slot. So that gives you more challenges. Now, another approach is just use more cores. That is fine way of doing it, but then every core has its local memory, so you are increasing the area. And again, now you need a multi-core processing software environment, and also that may not be the most efficient way. Now, there might be some situation you may still decide to use that multi-core, but it has its own con, and area and the processing power becomes the challenge. Now, the other thing would be run processor at higher frequency. Sure, higher frequency, you pay what you get. I mean, that's what I like to say. But over there, what it gives you is increases power, increases area. So there are various options. Each one, there are pros and there are cons for each of those.
So we've talked in previous Chalk Talks about Tensilica processors P5 and P6, I think. Where are we now in the evolution of this line?
Tensilica has been in Vision DSP market. We actually introduced our first Vision DSP in 2013, IVP32, and every year since then we've been introducing a Vision DSP. So in 2016 we introduced Vision P6, Vision and AIDSP. In 2017 we introduced Vision C5 AI specific DSP, and today we are introducing Vision Q6, which is a continuation of Vision P6 DSP. It's a follow-on to Vision P6 DSP, and that's why it's called Vision plus AIDSP.
Okay, cool. So what are the main features of the new Q6?
Yeah, so Vision Q6 is our 5th generation Vision and AIDSP. As I said earlier a minute ago, it is a follow-on to Vision P6 DSP. One of the main innovation we are bringing here is that it is built on a 13-stage processor pipeline. So that's our new 13-stage processor pipeline. And with that, because of that, we are able to achieve 1.5 gigahertz peak frequency. We are also able to achieve 1.5x performance for Vision and AI application. We are able to achieve 1.5x frequency in the same floor plan. When I'm comparing this performance, we are comparing that against our previous generation Vision P6 DSP. And when I quoted the frequency 1.5 gigahertz, and also I'll be talking about the power in a second, we are talking about 16 nanometer process technology. So I talked about 1.5x frequency in the same floor plan area compared to our Vision P6 product. And the most important one is the 1.25x power efficiency at Vision P6 peak performance. So as we've been talking about this target market, this applications segment that we are in, the power is very key. So as we start increasing the performance, we have to make sure that we don't increase the power. And with Vision Q6, we are able to make sure that the power consumption does not go high at the peak performance that our customers are looking for.
Those are some impressive numbers. Now, how does Q6 perform in benchmarks?
We talked about in terms of frequency increase and 1.5x performance in Vision and AI. And this slide over shows you specific kernels for imaging and vision, like some filters, some optical flow, some transpose, even matrix multiply, where up to 2x performance increase can be seen on Vision Q6 DSP compared to our Vision P6 DSP.
Okay, wow. And how does Q6 get all of this improved performance?
So there are 3 main areas that we focused on. The main thing we already talked about a 13-stage deeper pipeline. So diagram over here shows you how those 13 stages are achieved. So 13 stage, the instruction fetch, decode, scalar pipeline, and a vector DSP. So here you are looking at a vector pipeline and a scalar pipeline. Another thing which is very important for a deeper pipeline is that when you have a deeper pipeline, you need to worry about your branch, because any code you write, and if there is a branch taken, there is the branch penalty increases for a deeper pipeline. So we have a very sophisticated branch prediction mechanism. So that's the deeper pipeline. That's the processing part of it. Then second part is the area for the system. So we have a separate master and slave AXI, and we also have added the 2-channel DMA. Now, on top of it, every generation of our vision and AI DSP, we also focus on increasing and optimizing our instruction set. So we have also optimized our vision and AI instruction set to increase the performance.
Now, what about the software that I've got that works on previous generations of Tensilica processor architectures?
Yeah. What happens is that, as you ask me, the software is the key for any market segment, especially for this Vision and AI DSP. For Vision and AI DSP, all our customers want to preserve the software investment that they have made. So Vision Q6 is a superset of Vision P6 DSP in terms of instruction set. So Vision Q6 is source software compatible to Vision P6. So you can take the Vision P6 code, recompile it on Vision Q6, and it will run. So a customer can preserve the software investment on it. The other thing is that we are an integer machine, fixed point, 8-bit, 16-bit, 32-bit, but we can also provide you the optional vector floating point, 32-bit and half precision. And this is important because if our customers may have a GPU code that they may have written on floating point, then they can bring the GPU code on the Vision Q6 DSP. So till now, we have focused on the vector processing, but the scalar code is also very important. So we have a separate scalar processing pipeline, and that allows you to also have a separate scalar data cache. And in the end, we get a much higher scalar performance. And we also, customers don't have to spend a lot of time optimizing or arranging the scalar code because of the scalar data cache.
Now, we've been talking about single processors, but what about multi-core implementation?
Yeah, so Vision Q6 could be put in a multi-core environment. Our customer can put multiple Vision Q6 on an AXI interconnect. Another way for the Vision and AI implementation, as you know, we have a specific Vision C5 product targeted at AI that gives you 1 teraMAC processing capacity. Our customer can put a Vision Q6 and then multiple Vision C5 next to it to get a Q6 and a multi-core Vision C5 solution for a vision and AI experience.
So we've been talking a lot about hardware. Let's jump on over to the software side.
We bring multiple software solutions with this product. As we have mentioned and we talked about earlier, that DSP without software is of no value. So one of the target market and one of our customer that we already talked about earlier are Huawei and MediaTek, who are in the mobile market. And as you know, over 80% of the market is an Android phone. And Google announced Android 8.1 Oreo with Android neural network support. And with the Android neural network support, an application developer who is writing a neural network application in Java doesn't have to worry about if the application will be accelerated using the hardware underneath that or not. So for that, for a company like us needs to provide plumbing to take advantage. So we provide a necessary Android neural network DSP driver, Android neural network HAL, machine learning library, and support Android neural network API for Android 8.1 Oreo.
Okay, and that was for Android. But what if I'm on Linux and have used Caffe or TensorFlow? How do I take advantage of your DSP processors in that situation?
Yeah, so all other market segments, surveillance, automotive, where a lot of our customers are developing their neural network using Caffe and TensorFlow. So in this situation, what we call an offline training, where you have a network definition and you have a network weights or network coefficients in floating point. And the biggest task the customer has is taking that and generating highly optimized fixed point code for our DSP. And for that, we provide provide extended neural network compiler and a neural network library so that customers don't have to worry about programming the DSP. So for example, if you are a system vendor who is building a system using a DSP-based SoC, then you can focus on developing the neural network and not worry about programming the DSP. You could use this neural network compiler, and by using this compiler, you can generate the code for the specific DSP, the P6, Q6, or the C5.
So for inferencing, we have different requirements than for training when it comes to floating point versus fixed point. Am I right?
Yeah, that's correct. As we've been talking about all this time that we are a fixed point machine. And then previous slide, I talked about that we generate the fixed point code. And the biggest question that comes in everybody's mind that if I do the training in floating point, and then if I do the inferencing using the fixed point, especially 8-bit fixed point, am I going to get the performance that I expected, whether it's a classification or object detection, whatever your network happened to be. So here we have run some comparisons with floating point against 8-bit fixed point for AI processing. And you can see that top 1 or top 5 errors are negligible. All those results has negligible accuracy impact. All of them are within 1% of the floating point error.
Okay, now we've been talking about AI a lot. Let's look more closely at the vision side.
As we talked about, the Vision Q6 is not only a AI DSP, but it's also vision focused. So our customers that we work with are focused on both vision and AI software, and we provide them the infrastructure for OpenCL. We provide infrastructure for OpenVX and also for embedded C or C++ programming. And specifically for all of this, we provide OpenCV-based imaging library. We have over 1,500 imaging library, what we call them Extensa imaging library. Those are highly optimized for each DSP within Q6, P6, P5 so that the customer can get optimum performance and they can quickly develop their software.
Now, this all sounds cool on PowerPoint, but let's talk about some real-world examples. Is this running anywhere yet?
Vision Q6 is available right now as an IP, but our previous generation Vision P6 has already been implemented in silicon. You already actually saw some example in phone, in a MediaTek example, Huawei Mate 10 example. Huawei actually announced a P20 phone also based on Kirin 970. But in parallel, we have also worked and created a P6-based silicon and a software development platform that we demonstrated at Consumer Electronics Show in Las Vegas and Mobile World Congress. On the left-hand side, you see an image classification XNC demonstration. And the main purpose of this demonstration was that in the previous slide, if you remember, I talked about Extended Neural Network Compiler. And over there, you can take TensorFlow or Caffe-trained network and bring it all the way to your hardware. And here we took a MobileNet example and also Inception example, those two classification network, and brought it from the TensorFlow all the way to this hardware platform in less than a day. And that's the power of that extended neural network compiler. And on the right-hand side, on the same hardware platform, we work with our software partner, and that software partner brought a tiny YOLO-based people detection algorithm on this platform. So this camera is looking at the people, and every time it detects the people, it's drawing the rectangle on the people.
Now, I know it takes a whole village to do AI and vision. So who are some of the partners in your Cadence ecosystem?
You're exactly right. In order to work on this DSP, we are providing IP, we are providing all the necessary tools for AI software, we are providing all the imaging library, neural network library, but with that, as part of the ecosystem, we work with a large number of partners in various geography who are trained, who knows how to work with our tools. So here are some of the example of the software companies and application companies who knows our environment. We are also a member of Kronos Group and chairman of OpenVX working group. So we are driving the OpenVX specification also.
All right, this was a lot to take in. Let's go over your main points one more time.
Yeah, thanks. So the main message that we want to give is that in this market segment, the market needs both vision and AIDSP. Image processing, vision processing requirements are increasing. New experience, more resolution, large number of sensors, all of them are driving the imaging and vision requirement. On-device AI experience are increasing, and neural networks those are powering this are evolving every day. So you need a flexible solution. And A Vision Q6 is what we are introducing right now that gives you 1.5x performance in same area as Tensilica Vision Q6 DSP. It's built on the new 13-stage processor pipeline. It's 1.25x power efficiency at Vision P6 peak performance. It's a complete AI software platform, also comes with its Android neural network XNNC to meet market needs. And Vision Q6 is a vision and AI both DSP. So thank you very much for your time.
Excellent. Well, I think that's all I have time for today. Thank you so much for joining me.
All right, thank you.
And before we go, you didn't forget to click that link, did you? There you can find more information about Cadence's Tensilica Vision 6. For Chalk Talks, I'm Amelia Dalton from eejournal.com. For more Chalk Talks, head on over to the Chalk Talk section of EE Journal or check out YouTube, keyword EE Journal.